Imagine this: a spacecraft launched before the internet, before smartphones, before most of us were even born, is still traveling through space. It's farther than any human-made object has ever been, and it just sent back a message that shocked scientists around the world. Voyager 2 has officially left the sun's protective bubble, crossed into true interstellar space, and what it found out there may rewrite everything we thought we knew about the galaxy, and maybe even our place in it. And wait until you hear what might be waiting beyond. For more than 4 decades, Voyager 2 has been traveling steadily outward, leaving behind everything familiar: the planets, the Kuiper Belt, even the sun's solar wind. It's now billions of kilometers away, in a region of space we once thought was nothing but empty darkness. Launched in 1977, Voyager 2 was never meant to last this long. It was built with 1970s technology, computers weaker than the chip inside a modern microwave. And yet it continues to function. It continues to whisper to us from the edge of everything. And what it whispered recently was anything but routine. For more than 4 decades, Voyager 2 has been traveling steadily outward, leaving behind everything familiar: the planets, the Kuiper Belt, even the sun's solar wind. It's now billions of kilometers away, in a region of space we once thought was nothing but empty darkness. Launched in 1977, Voyager 2 was never meant to last this long. It was built with 1970s technology, computers weaker than the chip inside a modern microwave, and yet it continues to function. It continues to whisper to us from the edge of everything, and what it whispered recently was anything but routine. You see, for decades, scientists imagined that the solar system didn't have a sharp edge. Instead, they pictured it as a fading gradient, where the solar wind slowly lost power and blended into the interstellar medium, the thin gas and dust between stars. But Voyager 2 proved them wrong. When it crossed the heliopause, the outermost boundary of the sun's influence, the change was sudden, almost violent. Radiation levels spiked by more than 70%. The plasma around the probe became denser, and the magnetic field abruptly shifted. It was like punching through a membrane into an entirely different universe. Voyager 2's data didn't just confirm that the heliosphere, this bubble around our solar system, is real. It revealed that it breathes. Every 11 years, as the sun cycles between active and quiet phases, this bubble expands and contracts. During active years, solar wind pushes the bubble outward, shielding us more from cosmic radiation. During quiet years, the bubble shrinks, letting more galactic particles reach us. And it's not even a perfect sphere. It's shaped more like a comet, with a long tail streaming behind us as we drift through the galaxy. That means our planet's protection isn't constant. It's thinner in some places, stronger in others, and constantly shifting. This discovery changed how we think about cosmic safety. It means there are times in history when Earth has been more exposed to galactic radiation, something that may have influenced our planet's climate, evolution, and maybe even mass extinctions. In 2019, Mission Control experienced a heart-stopping moment. Voyager 2 went dark. For hours, there was nothing. No data, no signal. Billions of kilometers away, a tiny spacecraft built before many of its engineers were born had gone silent. And then, just as mysteriously, it came back online. Engineers blamed aging hardware and possible software glitches, but tucked inside the mission logs were references to something stranger: spikes in electromagnetic activity, sudden changes in the magnetic field, and a burst of charged particles, all just before the blackout. Some scientists now suspect Voyager 2 passed through a highly energized pocket of space, perhaps a remnant of a supernova or something we don't yet understand. This was just the beginning. As Voyager 2 continued its journey, it started recording patterns that resembled weather systems. Waves of radiation, bursts of high-energy particles, magnetic storms that seemed to come and go. For the first time, we had direct evidence of space weather beyond the solar system. And this weather isn't random. Sometimes it lined up with distant supernova events we already knew about. Other times it came with no warning, suggesting the galaxy is far more turbulent and active than we realized. But perhaps the strangest discovery came when Voyager measured the galactic magnetic field. Scientists expected the sun's field and the galaxy's field to clash violently at the boundary, like two storms colliding. But instead, they were aligned, almost perfectly. How is that possible? Let me know your thoughts in the comments. And if you love space exploration, make sure to like this video, subscribe to the channel, and share this with your friends so we can keep exploring the universe together.